Simulations. The lesson essential goal, explain how using a simulation is related to experimental probability. So vocabulary, a blank is an experiment that is designed to model the action in a given situation. So this is simulation. And you probably do lots of simulations with video games and whatnot. So possible generators. So a generator simulates outcomes. So these are going to be random, like a cube, the spinner. If you look down further on your paper, you're going to see marbles. If you were to draw like a marble from a bag. There's also cards. So if you're to draw specific cards from a deck. So simulations often use models to act out an event that would be impractical to perform. So let's take a look at the first type of simulation, which is modeling equally likely outcomes. The scenario it gives us is a restaurant is giving away one of 5 different toys with its children's meals. If the toys are given out randomly, describe a model that could be used to simulate which toys would be given with 6 children's meals. So we have one of 5 different toys, and we're looking at giving it out for 6 children's meals. So we have to decide on what kind of simulator. So we could use dice here because there's 5 different dice, and we have 5 different toys. We can't use the coin in this instance because it's only a 50-50. You know, there's only 2 options here. But we could use cards. Now, these cards aren't going to work, but you could use like 1, which would be an ace, 2, 3, 4, 5. Or what I'm going to use is I have Uno cards. And I'm going to take and assign my Uno cards. Uno cards here, and assign each toy to a different card. In this case, I'm going to use a different color. Then I'm going to draw 6 times. I need to draw a card randomly, replacing the card back after each trial, because when we go through a drive-through and it's randomly and they have plenty of all these toys, they're all mixed up at random, they've been thrown in the boxes, you're not sure what you're going to get. So Raiden and I are going to try this out ourselves. You get your own simulator and try this out and see how your results compares to ours. Alright, so we're going to do our simulation, and I have Raiden here to help us, and we're going to use our Uno cards. So we're going to mix them up, and if you were to drive through, let's say, a fast food restaurant, it's not practical to do that 5 times. As much as most students and most kids would love to do that, we're not going to. So we're going to simulate it, so we're not buying 5 Happy Meals at 5 different times, right? Alright, so the first thing is you mix them up, and then I'll let you see. Oh, no, you can't see. You're going to see it in the video, aren't you? Because we got it forward facing. Alright, so I want you to pick a card, and let's see which toy we get. So the first one we get is the green toy. So I'm going to write that down, and then we will, that one's assigned toy 1. 1 is green. Let's say 2 is red. 3 is yellow. 4 is blue. And toy 5 is the wild card. Sound fun? Alright, so let's try this again. We're going to mix it up. So go ahead, pick another card. Let's see, we're driving through the drive-thru. What do we get now? We get the wild card toy on the second try. So be writing it down. Haha. Oop. There goes our toy. Alright, let's try it again. Alright, you ready?
Yep.
Pick a toy. He got the red toy.
Yeah. I love their color red.
I know.
Ew.
All right, air.
No. Ew.
All right, you ready? All right, he's gonna pick another toy. That's 3. We gotta go to 6, but it's out of 5. Oh, you can't see the toys. 5 different toys. Which one do you want to pick? Oh, look at that. He got the wild again. So twice we get the wild card. Now the probability theoretically is you should get each one out of 5, but we're replacing the card each time because in the drive-thru they got tons and tons of toys. All right, pick another card. We got 2 more to go. Ready? He got the green toy. So, all right, so one more time. Let's mix it up. So that's, wow, twice the green and twice the wild. What you got? Oh, he finally got a blue toy. Look at that. So 1, 2, 3, 4, 5, 6. There it goes. Make sure you log it on there. This is how you do a simulation. So we're not actually buying 5 Happy Meals and spending like $25 to $30. All right, so I assigned toy 1 green, 2 red, 3 yellow, 4 blue, and 5 the wild card. So when we did our trials, as I tallied, the first toy was green, so that's toy 1. The second one was a wild card, so that's toy 5. My third trial was a red, that was toy 2. My fourth trial was a wild card again, so that was 5. And then the next was green, so I got another toy 1. And the last was a blue card, so that was toy 4. So when we look at our probabilities, the probability should be 1 out of 5. So theoretically, it should be 1 out of 5. And just like when you did your experimental probability, we can see here that it doesn't match our theoretical, because out of our 6 trials, toy 1 was actually chosen twice. So that's 2 out of the 6 trials, if we're just going to use the trials in general, which is 1/3, which is greater than that theoretical. Dress for success. Mr. Chen must wear a dress shirt and tie to work. Each day he picks one of his 6 ties at random. Design a simulation that could be used to model the situation. Use your simulation to find out how many days Mr. Chen must work in order to wear all of his ties. So he has 6 ties and he's going to pick them at random. So he just picks them in the dark. So we're going to use something that can generate 6 different ties. So we could use a dice, we could use cards, you could use marbles, you could use 6 different colored crayons, whatever you have. So we're going to use a dice. You can use whatever you have and write that into that blank. And we're going to assign each tie to a number. And the numbers are 1 through 6. So those are going to go with each of those ties. Repeat the simulation until all. So we're going with all of them, meaning we have to get all 6. So how many times is it going to take for us to roll the dice to get all 6 ties? Do we replace that generator? Well, here the dice, it's a hard yes, because we can't take like one of the cards away. Here, we're always going to replace that number, because he's replacing the tie back into his closet and then taking it out maybe the next day, or maybe a different one the next day. So we're going to use the generator and simulate how many days it would take Mr. Chen to wear all of his ties. So watch me and Raiden do this, and then you try it out, and let's see how close you get to our days. Have fun. All right, so here we go. We have our ties, 1, 2, 3, 4, 5, 6, and we're going to use the dice, and Raiden can roll it here. Go ahead, grab the dice and roll it. And let's see what we get tie number 1. And so we're just going to use tallies here. Go ahead, roll the dice again. We get tie 1. And look at that. He gets tie 1 again. Roll the dice.
I love it.
This is fun.
Yeah.
All right, roll it again. And Mr. Chin decides he randomly chooses 5 the next day. So we're 3 days in. Roll the dice. Oh, there it goes. You got to roll a little more carefully. It was on 4, so he rolled 4. Okay, here I'm going to choose the tie. And we get a 6. Go ahead, you roll. Don't roll it off the table, just. And he rolled a 6. Okay, rolls. I'm going to roll, my turn. And whoa! 3 days in a row. They're going to notice it's, I think, at work. He keeps wearing that 6th tie. We still need tie 2 and 3. And we get a 5. All right, come on, roll it again. And he rolled a 1. Wow. All right, let's keep going. What's the next tie? Is he going to get a 2 or a 3? Oh, it went off the table, but it did land on 2. All right, we still have to get tie 3. Let's see, can we roll a 3? Maybe he'll randomly pick that tie. Nope, he likes tie number 5. Okay, ready? You roll it. Roll it. We're still looking for tie number 3. And off the table it goes. This is just like the classroom. What number was it? 1? It was 1. It was 1. All right, let's see. What do we get here? 4. I think this is a trick dice. A 5. A 6. My goodness. That tie number 3 must not be a good looking tie. All right, you ready? 4. Where is the 3? Oh, there's our 3. All right, so now he's randomly chosen all the ties.
Yeah.
Now we're going to add these up. So we have 5, 6, 7, 8, 9, 10. 10 and 4 is 14, plus another 4 is 18. So it took 18 days, 18 work days, which is probably over 3 weeks of work to wear all of his ties. So do this simulation yourself and see how close you get to our simulation. Is it exactly the same? Does it come out different? I'm betting on different. Have fun. All right, so when you're done with your experiment, your simulation, come down here and answer this question. How many trials did it take to get every tie for myself and Raiden? It took us 18 trials, meaning 18 days. So it's a 5-day work week. We're talking about over 3 weeks to wear all 6 ties. Another type of simulation is modeling unequally likely outcomes. So this problem says, during the regular season, Jason made 80% of his free throws. Describe an experiment to find the experimental probability of Jason making his next 2 free throws. So we know 80% of the time he makes the free throw, and 20% of the time, remember it's complement, he does not make the free throw. So we're looking for the probability experimentally through this simulation for his next 2 free throws. So first, let's change this percentage to a simplified fraction. So we know that this is 80 out of 100, which is, if we take and simplify this, we can take off those zeros, 8 out of 10. But we can take this, this means that we're going to have to use 10 different items. Let's reduce that down to half that. So we can say 4 out of 5 are free throws that he makes, and then 1 out of 5 are the ones that he misses. So when we do this, you need something that will simulate 5 different outcomes. So we can use the cards again, and in this case, we'll use colored cards. You may choose to use, again, crayons or marbles or something. Maybe if you don't have exactly the same color, you could always use different shades of the same color to represent free throw that's made and then one that's missed. And where 80% or blank represents making a free throw. So we're going to say 4 out of 5. It represents making a free throw. And we want to repeat the simulation how many times? So let's come back up here. It says the next 2. So we want to repeat it 2 times. So go ahead, you try it out. Use cards, use a random generator on Google if you need to. And let's see if you come up with the same 2 trials that Raiden and I do. All right, so here we go with our free throws. We have 4 greens that represent making the free throw, and then this 1 wild card for missing the free throw. And we only have to do this twice because we're just looking for the next 2 free throws. So let's turn these all the same direction, mix them up. You're going to choose one, Raiden?
Yep.
All right, so let's see, what you got?
Green.
He picked green, so made the free throw here. Now 80% is likely that he's going to make the next 2 free throws, but let's see if he misses the next one. Okay, you ready?
Yeah.
All right, so pick a card.
No.
And another green, look at that. So here's my wild. He made the free throw twice, and knowing that we have an 80% chance, it is more likely to make the free throw than to not make the free throw. In this case, the simulation shows the same thing, that it's more likely that we are going to make the free throw in our simulation than that one miss. So log it on, you try it out yourself, and do you get the same results? Let me know. So here on our trials, I know that he made the first and he made the second, which goes right along with this 80%, which is an awesome rate of his free throws. So going back to the lesson's essential goal, we wanted to compare simulations to experimental probability, which you already did the theoretical and experiments already. So here, a simulation, write that in, is a process to collect data from which the probability or experimental probability can be calculated. So what I want you to do on this practice is take a look at the previous problems as you go through here and come up with a simulation yourself. It can be one that we've used, or it could be something like a coin toss, depending on how many different possible outcomes you have here. So just quickly, an ice cream store offers waffle cones or sugar cones. Each is equally likely, this is important, it's equally likely to be chosen. Describe a model that could be used to simulate the situation. Based on your simulation, how many people must order an ice cream cone in order to sell all possible combinations? Okay. Number 2, players at a carnival game win about 30% of the time. Remember, we're using the complement to this also. So based on your simulation, what is the experimental probability that the next 4 players will win? And then do that experiment, use that as simulation, and see if it comes out that a similar percentage actually wins, okay? So you have fun with this and let me know how you do.